Hi everyone, I'm back again and I'm going to be giving you a lesson on the gas laws in less than 5 minutes. So we have 6 gas laws, but I'm only going to focus on 5 of them right now. We have Avogadro's law, Boyle's law, Charles' law, Dalton's law, and Gay-Lussac's law. You might recall me telling you that if it's a law, it likely has a mathematical formula that goes with it. And these are no exception. So we see that Avogadro's law is actually volume divided by the number of moles is equal to volume divided by the number of moles. And the 1 and the 2 stand for initial and final, so before and after. Boyle's law is pressure and volume. So we see that the initial pressure multiplied by the initial volume equals the final pressure times the final volume. Next, we have Charles' law, which relates volume and temperature. So we have the initial volume divided by the initial temperature is equal to the final volume divided by the final temperature. Then we have Dalton's law, which is the total pressure of a system is equal to the partial pressures of the gases that make up that system. So if there are 3 gases, it'll be the partial pressure of the first gas plus the partial pressure of the second gas plus the partial pressure of the third gas. And finally, we have Gay-Lussac's law. And it says, sorry about this, I messed up. It says the initial pressure divided by the initial temperature is equal to the final pressure divided by the final temperature. Now, I'm not going to ask you to do any math in this with these particular gas laws. All I want you to do is understand the concepts. So Avogadro's law relates volume and the number of moles. So as I add more moles of a gas to a system, they will occupy more space, which means that as I increase the number of moles of a gas, I'm also increasing the amount of volume they take up. That means Avogadro's law is a direct relationship. It shows a direct relationship. Boyle's law relates pressure and volume. And like you saw in the demonstration with the PEEP marshmallows, as I decreased the pressure inside of that chamber, we saw the volume of the marshmallow expand. The same is going to be true when we talk about gas particles. If I am decreasing the pressure, the gas particles will expand and occupy more space. So this, Boyle's law, shows an inverse relationship. Charles' law relates volume and temperature. So as I increase the volume in a system of gas particles, they're going to move faster, their energy will increase, which means they will occupy more space. So Charles's law also shows a direct relationship. Next we have Dalton's law, which it's pretty straightforward. We find the total pressure of a system by adding up the partial pressures of all the gases that make up that system. And finally we have Gay-Lussac's law. So it relates the pressure of a gas to the temperature of a gas. If I increase the temperature of a system, we will also see the pressure of that system increase. You all saw this when you thought about the Lysol can or any aerosol can in general. As the temperature increases, the particles will move faster and the pressure inside that can will increase. So this also shows a direct relationship. In fact, Avogadro's law, Charles's law, Dalton's law, and Gay-Lussac's law all show a direct relationship. Boyle's law is the only law which shows an inverse relationship.